when I put inverses together with respect to whatever that thing is, and maybe it's not just an operation, maybe it's something else, but when inverses get thrown together, I get the identity for that operation. Okay? Same thing happens with multiplication. Okay? For multiplication, what number out there would be the multiplicative identity? What number can I multiply and get that same number back? Yeah. 1. 1's our multiplicative identity. So 8 times 1 is 8, and 1 times 8 is 8 as well. And that seems silly to say because, you know, multiplication, as far as we know, is commutative. I can turn that order around and get the same answer. Okay? So this property of 1 makes it the multiplicative identity. I multiply things by 1, and it doesn't change that number. I get the same value back. So does anyone know what multiplicative inverses are? They exist, and you know what they are, but we usually call them something else. So for example, if I had 2/5, what would I multiply 2/5 by to get 1? 5 over 2? We normally call those reciprocals, right? But we also call them multiplicative inverses. Because when I multiply reciprocals together, I get the multiplicative identity 1. Deal? I know this is all very exciting stuff. No, actually, if I'm being candid, I really do find this stuff fascinating. Maybe not on the first grade level, but when you, I think it's really cool stuff. Okay. So, same idea. You put inverses together with respect to that thing, multiplication in this case, and you get the identity for that thing, right? So that's that's the groundwork for inverse functions. All right. Before I can talk about what kinds of functions give me inverses, I need to first talk about the identity for a function. Okay. We have mentioned it before. It was a couple weeks ago, but I'm curious. Does anyone remember the function that we call the identity function? Yeah, that was like the second week of class. It's our y equals x. That ring a bell now? Just fake it. Say yeah. Yeah, rings a bell now. Cool. Why is it the identity function? Well, when I go over here and I pick a value for x and plug that in, what value do I get back for y? The same one, right? It's the identity function because when I plug numbers into this function, I get the same number back for y. Okay? So the y equals x is my identity function. F of x equals x. So our definition for our identity function, for inverse functions, are the functions that I put together some way and get that identity function x back. Alright? So, the thing that we're putting them together with is compositions. So if I've got two functions, f and g, and I do a composition, I do f composed with g, I do f of g of x. When I do that, and I get the identity function x back, if that's true, that's only part of the piece. Okay? Because one of the things we said about compositions, remember, is it matters which one I do first and which one I do second. Right? So if I do this one first and then this one second, I get that. That doesn't mean if I turn it around, I'm necessarily going to get the same thing, right? So what has to happen is this has to be true, and that has to be true. If the composition in both directions gives me the identity function x. Then f and g are inverse